Okay, welcome to the September 19th edition of Climate Verso. My name is Ned Komar, and today my two guests are Matthew Wielicki and Peter Fiekowsky. Matthew and Peter, great to have you, and I'm delighted to introduce the two of you to each other. I'll give you a chance to introduce yourself to our audience in a sec. But this all just came up on Monday, the idea of having the two of you on the podcast. I'm a subscriber to Matthew's Substack, which is called Irrational Fear. And I got an email. I woke up Monday morning. There's this email from Matthew talking about his view on the issue of geoengineering. I'm not going to describe what that is right now. We can get into that in more detail later. And Peter, you had already indicated an interest to be on the podcast, but I wasn't sure who I wanted you to talk to. But in the past, and Peter and I, we've known each other, I think, for 8 years. Peter and I have touched on the issue of geoengineering. I don't know much about it, to be honest with you, but I know Peter is interested in the issue. So I sent him Matthew's Substack article and said, what do you think? Do you want to be on the podcast with Matthew? So here we are, just a couple days later, actually recording this conversation. So welcome to both of you. And Peter, why don't you start? Just take a minute or two, say what you do, who you are, what your interest is in the climate issue.
Yeah, so I'm Peter Fiekowsky. I'm a physicist from MIT, living here. I've been in Silicon Valley for about 50 years, and I've 27 patents. And my claim to fame is having established the field of climate restoration. And climate restoration simply means the commitment to giving our children the same safe climate that we were given when we were kids. And it's not very heavy. It's quite obvious because it's sort of like discovering air. It's always been there, but until you say it, it's not discussed. So I have established quite a few nonprofits to achieve the result. And achieving the result of restoring safe CO2 levels is a matter of replicating what nature has done many times before ice ages, removing the massive amount of CO2 that we need to remove, that we've put in the atmosphere. So that's who I am in a nutshell.
Okay, Peter, that's great. We're going to get way into the nuts and bolts and details of what you're talking about, but that's a great introduction. And just what's the name of your organization that you created?
Well, there are several. RestoreTheClimate.org is the most recent.
Oh, okay. I'm familiar with another one, right?
Yeah, Foundation for Climate Restoration. That one is 7 years old, and it's great. And it's more addressing a lot of the concerns from 7 years ago.
Got it. Okay. All right. So thanks for introducing yourself to our audience. And Matthew, you're next.
My name is Matthew Wielicki. I'm a earth science, a former science professor at the University of Alabama. I'm a geochemist by training, and I'm primarily now the author of the Irrational Fear Substack.
And you're now living in Colorado, is that right?
That's right.
Okay. And Peter, you're in California?
That's right.
And I'm in New York, but here we are. We're all together. Okay. It's just the wonders of the post-COVID era. Matthew, talk a little bit about the article that I read on Monday morning.
So I believe you're talking about iron fertilization. So this is one of the subsets of a few of the types of geoengineering projects that are being explored right now. I put them into two categories. There's essentially solar radiation management, and that's going to be trying to control or reduce the amount of solar radiation that reaches your surface. And then there is carbon dioxide capture and storage, and that would be something like iron fertilization. So in this idea, what you do is you find areas in the ocean that are essentially nutrient rich, but they lack iron. And that's what's essentially reducing the plankton and the algae to grow. And you fertilize those areas with iron, the algae grows and blooms. And as it does, it builds its organism through sequestering a lot of carbon. And eventually those organisms die, they sink to the bottom, they get buried under some sediment. And the idea is that you can store these things over centuries. We don't really know the full time period, but it's a way to start to remove CO2 from the atmosphere.
Got it. Okay, terrific. That's a good thumbnail sketch of your article. And Peter, before I have you respond, the basic purpose of Climate Verso is to bring together climate professionals, whether they're scientists or activists, or they could be economists. There's no limit to anybody who has an interest in climate. But in particular, I'm looking for pairings of climate professionals or just or serious amateurs like me, who see the world of climate, the issue of climate, from different perspectives. There's at least two in my mind, but there's probably lots more. So certainly, Peter, I think of you. In fact, that's how I even know you, Peter. I went to the conference where I met you in 2016. I went there because I heard there were going to be a lot of people there who were really worried about climate change. And, look, I'm trying to be a neutral party here, but I'm not, right? So it would be ridiculous for me to claim that I don't have a point of view. I do. Anyway, my point of view, and I've had this point of view for at least 20 years, is that the climate crisis is overblown, let's say. Like, I just don't think that the science really matches the fear that's out there. So I went to the conference to meet you, Peter. I didn't even know who you were. I just had heard that there were people at this conference who were really worried about climate. So when you and I first met, I remember, I don't know, I think we kind of argued a lot. I don't know, but we've stayed connected over 8 years. And in fact, when I first came up with the idea of trying to do something to get people to talk kind of across the fence, so to speak, you were one of the first people I called. And you've been extremely supportive of what I've been trying to do here. So anyway, I'm getting us a little bit off topic, but so let's get back on topic. Peter, one other thing is, Matthew, there was a lot of technical information in what you just said. Peter and I probably understood everything you said because we're climate nerds, okay? But I don't know, we're trying to target an audience that includes climate nerds, but includes a broader audience. So I'm going to actually ask each of you, when you're responding, if there's something you heard in what the other person said that you think might not have been totally understandable to a general audience, please put in what you think might be useful, and I'll do that too. But I'd rather hear it coming from you guys than from me. So anyway, Peter, you're next. What do you got? What do you got to say there?
Well, Matthew, as I understand it, what you're saying is that there's a lot of discussion about how do we cool the planet, how do we restore safe CO2 levels, and why would we do that? Is there enough justification to make something happen intentionally? And I think it's an excellent question. That really was the turning point for me when I came up with an answer for why would we want to meddle with the climate. The answer that I discovered is that I want my children to have the same safe climate that I was given. And really, it's just that simple. And there's no scientific reason for that. We do know that you can never go back, right? So when I visit my old elementary school, it is totally different than I remember it. There is no going back. There's no restoring the actual climate. But on the other hand, we do know that the last time CO2 levels on our planet were as high as they are now was about 14 million years ago. And at that point, it was 10 more million years before the first Homo erectus, the first of our species, started evolving. And it was just a long time ago. So if we don't restore safe CO2 levels, we have no idea what will happen for our kids. And and
Peter, let me interrupt you there. I think that was a real clear response, and in one of the things you talked about was the concept of safe CO2 levels. So, Matthew, could you? I'm guessing you have a somewhat different perspective on that issue. Um,
Uh, sure. Yeah, there's no such thing as a safe CO2 level. That's a complete misnomer. In fact, in the rooms that we're sitting in right now, it's probably 800 ppm. I used to take a CO2 monitor.
wait, Matthew, what does ppm mean?
So that's parts per million. So the atmospheric concentration of CO2 in the atmosphere is 0.04%. Another way to say that is it's 400 parts per million. Those numbers are equivalent to each other, but instead of talking about 0.04s, we end up talking at 420 parts per million. And that's what the atmospheric CO2 is currently at the Mauna Loa Observatory, maybe 422 actually today, or even 423. But in our room today, right now, in the rooms that we're sitting in, it's very likely 800. And I used to take a CO2 monitor when I lectured at the University of Alabama. And the students were shocked to see that when they were leaving the lecture hall, I have 353 students in a lecture hall, and the CO2 was 1,100 parts per million. In fact, for plant photosynthesis, for both C3 and C4 plants, the optimum CO2 would be on the order of 11 or 1,200 parts per million. Mammals evolved at 1,100 or 1,200 parts per million. So that's an absolute fallacy that there is a safe CO2 implying that there's an unsafe CO2 level.
Peter, I'm going to let you respond to that because I'm guessing when you say safe, you're not talking about the safe level for humans in terms of what we can breathe in a room, right? Or if we went into a submarine, right? I imagine the CO2 levels in submarines get even higher, right? But I think what you're talking about is the concern from a safety standpoint that as CO2 levels go up, which they have been doing for the last 200 years or so, that they will cause the Earth to get warmer, and that's what you're concerned about. Is that what you mean when you talk about safety?
yeah, well, it's a bit more complicated. It's the ecosystems on our planet change as the CO2 levels change. Now, there's a warming that happens when the CO2 goes up and down. And as Matthew could tell you, probably at great length, it's very complicated, the correlation between CO2 and temperature. And so, ignoring the temperature, it's easy to measure CO2. And and it's also easy to control CO2. You can either burn a lot of coal and increase CO2 levels on the planet, or you can increase photosynthesis in the ocean the way it happens before ice ages and reduce CO2 levels on the planet. And the the sense of safety, I think we all agree everyone's going to die eventually. So it's not like if there's a certain CO2 level at which point no one dies anymore. I think that's off the table. So what I mean by safety is sort of like this: that um, if when I put my kids on a plane, and there's a new plane which is more efficient, it's got better bathrooms and better lighting. What I'm going to do is I'm going to say, listen, how many times has that plane flown? And if the answer is not really yet, I'm going to put my kids on the older plane, which has flown a million times. And so our society has, and our civilization and our agriculture evolved with CO2, global CO2 levels and whatever temperatures and and biomes that were corresponded with that CO2, but CO2 levels right around 280 parts per million. And then in the history of Homo sapiens, we've actually experienced and lived through levels as high as 300 parts per million. Now, above that, it's speculation, right? Because we don't have any data on has our civilization and agriculture survived above that. Now,
Peter, one of the things you said, I'm just going back, rewinding about a minute. You said we know how to control CO2. If we want more CO2, we could burn more coal. And what is it that you said about how we could reduce CO2?
we can add nutrients to the ocean like in before ice ages, cause more photosynthesis in the ocean, and the carbon turns into dissolved carbon in the ocean.
So let me just ask a devil's advocate question. How much of the current concentration of carbon dioxide in the atmosphere is a consequence of human activity as opposed to natural factors? And either one of you could address that.
Yeah. Well, I'll start out saying it's a red herring. Insofar as I'm a parent and now a grandparent, and I gave you my example of I want to put my children on a safe planet, which has sustained human life for more than 100 years, then I don't care what the cause is of the CO2 level. And so I just want to get the CO2 level back to levels that I know humans have survived and would likely survive.
So on an annual budget, the anthropogenic CO2 emissions contribute about 3 to 5% to the annual budget. This is one of the reasons that doing CO2 sequestration, you'd never even know if you were doing anything, because a tiny perturbation in any of the other major systems that contribute significantly more to the CO2 budget, if they change just a minuscule amount, how would you know if you're doing anything or not doing anything, right? So it's like trying to stop sea level rise with a teaspoon.
Can you give us some examples? I got that you're saying that human emissions represent 3 to 5% of the annual release
Carbon
of
budget.
which is what,
Yeah.
release of carbon dioxide into the atmosphere.
Well, it's the carbon budget. Yeah. So, every fall in the northern hemisphere, the leaves die and they emit CO2 as they fall off. And in spring in the northern hemisphere, you see a drawdown of CO2. So there's this annual just budget of CO2 that's traveling in the carbon cycle. And the amount that the anthropogenic emissions are contributing to that is about 3 to 5%. So it's very difficult to identify if you're doing anything, if your entire contribution is 3 to 5%. A tiny perturbation in any of the other systems that are contributing significantly more would drown out any of your contribution or removal. So it's one way that you'd never know your signal. But to add another point, to talk about safety, Peter mentioned that there's no way that CO2, we're going to have no more babies. There is a way. If you go below a certain threshold, this planet dies. So there is a low threshold. We don't know if there's a high threshold. We know that plants and animals survived in the thousands of ppm all throughout the Phanerozoic, but we do know for sure that there is a lower threshold.
What's the Phanerozoic?
The Phanerozoic is the last 550 million years. That's essentially, Phanero means visible and zoic means life. So this is the time period where we have visible life. This is the time period where the animals on the planet, they developed hard parts like teeth and shells and bones. And those things are very easily fossilized. So we have a very good record. Prior to that, you have soft-bodied organisms like jellies, sponges, and those are very difficult to fossilize. So we like to talk about the visible life period of the planet, known as the Phanerozoic, visible life. And that's kind of how we see the life change and evolve, because we actually can see the hard parts that we can see in the fossil record. Other than that, it's very difficult to preserve soft tissue.
Got it. And so what were you saying that we know about the Phanerozoic era?
That there's no upper threshold. So CO2 levels have been in the thousands of ppm. And in fact, during the Cambrian explosion, they were in the thousands of ppm. And we know...
And when you say, just to be clear, ppm means parts per million. Okay.
Parts per million. That's right. And today we're 400. So we're talking on the order of anywhere from 3 to 10 times more CO2 in the atmosphere. But we do know through laboratory experiments that there is a lower threshold. So photosynthesis really does start to break down below about 180 parts per million. And we were really pushing that lower threshold in these last few times. In fact, one of the only time periods on this planet that we've been oscillating in and out of glacial and interglacial cycles, which I would argue is not optimal for human survival and civilization, is the time period of very low CO2. If you look at other time periods on the planet's climate is very stable because what's happening now is we're at such low CO2 that the orbital forcing from what are known as Milankovitch cycles. This is how the moon and the earth, the sun and the earth interact. The earth is on a tilt, that tilt moves, that tilt wobbles like a top, and the distance from the earth and the sun changes. And those are really driving us now into these glacial and interglacial cycles. To imagine that that's some sort of optimum that we should protect doesn't make any sense to me.
Got it. Okay. That I learned a lot. I learned a lot from that. And please, Peter, please jump right in. Go for it.
Yeah. Yeah. So Matthew, as a scientist, I fully agree with you that life below 180 parts per million is a little sketchy, and above God knows what is a bit sketchy, and that for life that there's this wide range. And there's truly no scientific reason that we should be here, right? There might be a narrow range for humans and there might not, but scientifically it doesn't matter. In fact, as we go extinct, as we will eventually, it's going to be very interesting for science. So it's maybe better for science that we go into the region where we do go extinct. Now,
what if the scientists go extinct first?
That's really interesting, right? Because then maybe my argument as a grandfather takes precedence, where as a grandfather, I want my grandkids to have as exciting a planet to live on as I had. And there's no scientific reason for that. It's just cultural, but it's important. I like to say it a different way, which is humanity's on the stage of the planet right now. And for no reason, I'd like to stay on the stage, like us to stay on the stage as long as possible. But it's not, I agree with Matthew, there's no scientific reason for that. That's just emotional.
But Peter, your grandchildren are safer today from the weather and climate than they were ever. Your generation, they're way safer today. In fact, if we just look at the global statistics, all throughout everywhere, even developing countries, people are safer today than they ever were from weather and climate related trends because of infrastructure, because of energy, because of things like synthetic fertilizers that can get us through droughts, which are also the Haber-Bosch process, which requires fossil fuels. And so, it seems like you discount all the benefits that your grandchildren now have from living in a fossil fuel world. And you focus so much on this hypothetical model that anybody can tweak that's telling you that sometime in the future, things are going to get bad, because every metric right now, things are not bad.
Yeah. So Matthew, I think you're saying that life looks pretty good. Here in Silicon Valley, we've had just a reasonable summer, not that different than it was 40, 50 years ago when I first moved here. And and most of us, life is going on pretty well. That's certainly true. The issue is that it's likely the case that our humanity depends on the ecosystems we live in. And we may not, right? Because there are a lot of techno-optimists who say it doesn't matter about the ecosystems. We have robots and chemistry and so on that will supersede that. And and the techno-optimism aside, because you're right that we may invent our ways out of this. But it may be the case that we won't. It may be that we really do require a very high ecosystems with a lot of variety and so on. And as a parent, I'm obligated just to be very safe with my children and to take a risk and say, well, yes, humans have never survived for more than a few decades with CO2 above 350 or 300, and here we are at 425, I believe. And so far, so good. It's a lot like the scientist who jumped out of a 20-story window, and he was logging on his book how things were going. And at the second floor, so far, so good.
Peter, something you said to me, I think a couple of years ago was, um, I was talking about from my perspective, there's a lack of argument among climate scientists, that the climate scientists have put themselves into cliques. And there's the so-called mainstream climate scientists who say, we've got this crisis. And then there's a smaller group probably of climate scientists called the skeptics. And I think Matthew might consider himself a skeptic. At least I consider you a skeptic, whether you like it or not. But anyway, so there's this skeptical group of climate scientists who are saying, there's other factors lots of other factors that impact climate. But anyway, my complaint is that these groups of scientists just, maybe they talk to each other in private, but almost it is so rare that they talk to each other in public. And at the time, I said this to you, Peter, and I think you said, and I was interested and surprised by what you said. You probably remember what you said, but I'll just remind you just in case you don't. You said something like, well, that you didn't care about the science. Does that, yeah. So say more about that.
Yeah. Yeah. Well, as I'm sitting here thinking about what Matthew said, I suspect there's an assumption that Matthew is making, which is that to reduce CO2 back to what it was 50 or 100 years ago would be very difficult, because that is the assumption in science. And scientifically, that's correct. That is to say, science predicts the future based on the past. And when I was in college in the mid 70s, and I read about CO2 increasing, and I thought, well, we're going to have to get the CO2 out, because I don't want to find out what happens when CO2 gets above the highest level that humans have ever survived. We might survive, we might not. I don't want to be the test baby there. And I thought, well, we've had submarines for 100 years. The Apollo program was just finishing, and we know how to get CO2 out of the air. Now, back then, and it's still true, that getting CO2 out of the air, it costs about $1,000 a ton using the technology that they have in submarines and in spacecraft. Now, what we didn't know until 15 years later, until 1990, is that nature pulls CO2 out of the atmosphere essentially for free. And by then, I and most of the community had imbued our brain in it's going to cost $1,000 a ton to remove CO2. And they think that they can get it down to 600 or 300. I've heard people say 30, but then they gave up on that after we challenged them. That's using chemistry. If we, it doesn't have to cost much at all. And the scientific community doesn't acknowledge this for the most part. But if you look at the Keeling curve, which is the CO2 increase, since 1958, we actually had net zero after the Mount Pinatubo eruption. When that big volcano erupted in 91, there was a cooling effect because dust reflected sunlight out into space, and the Earth cooled by a half a degree Celsius or a degree Fahrenheit. But separate from that, there was a massive amount of dirt that got blown into the South China Sea next to the volcano. And what happened is, over the next year, 20 billion tons of CO2 disappeared. As I say, we were pumping 20 billion tons a year into the air from our airplanes and power plants and so on for the last, for the at least 10 years before that, and for the 10 years after that. But the CO2 level didn't go up during that year, which means that somehow the CO2 disappeared at essentially no cost. And there's very good reason to expect that it was photosynthesis, because no other process can remove 20 billion tons a year. And there's so much sunlight on the ocean that photosynthesis can do that. Anyway,
So, Peter, you're saying that this extra dirt from the volcano, the Pinatubo eruption, landed in the ocean, and then that. Say more about that.
yeah. Any of us who've had gardens know that you have to have the proper nutrients for plants to grow, and that's true in the ocean as well. And so most of the ocean is blue, which is beautiful, and you can see more, but it's not green. Green is when you have algae growing and photosynthesis happening. And if you want to remove CO2 from the atmosphere, you can do it on land, but it doesn't work well because trees die after a few decades, then they rot or burn, and the carbon goes back in the air. In the ocean, when you have plants, they and the animals that eat them when they die tend to sink. And in the deep ocean, there's very little oxygen and they don't rot. And that's the mechanism where nature stores 1,000 gigatons of CO2 before ice ages, which gives us a cold period. And so we can replicate that. And we've done enough testing and so on that it looks like it'll be like $1 billion a year to remove all, over 20 years, to remove all the excess CO2 and get us back to pre-industrial, get us back to what it was 100 years ago. And so, yeah.
All right, that's a great presentation. I definitely have more questions, Peter. But I just want to give Matthew. I just want to hear what Matthew. What is your response to what you're hearing so far? And Peter, I understand you've got more to say.
I just wanted to get one clarification. I think Peter might have just let it slip that he said that one of the predictions was all the way down to 30 ppm.
No.
No, I thought you said no. I didn't hear that, Matthew. I don't remember what I heard you say, Peter, is something like to get us back to where we were before the Industrial Revolution, something like that.
Yeah, which is 300. Well, I use the limit of 300 just because humans have survived below 300.
Yeah,
And so I
280
feel
or
safe
so.
giving that planet to my children.
Yeah. So, I mean, this idea of humans surviving, this is just from Antarctica. So these are ice cores. If you just go under the canopy in the forest, if you live in a forest area, you basically live and survive at 500 or 600. That's your natural average CO2. So the idea that, humans don't only survive at this average that is somehow extracted from the ice cores in the southern hemisphere, I don't buy that. But also, what's the number? What's the target number? Do we always go back to pre-industrial? Is that the number? Is that the natural CO2 right now? If humans didn't exist, would that be 280 ppm at the pre-industrial level? Should we always keep it at that and never let it fluctuate? Because then we're really messing with Mother Nature, because we know that CO2 fluctuated dramatically in history, right? All the way up to 6,000 or so parts per million, and now all the way down to about 220, 230, approaching the death zone. And so, what's the number? What's the target?
But I know Peter well enough that I think he's going to say, but humans weren't alive during that period.
But mammals evolved 170 million years ago. We shared the majority of our DNA with these animals. Let's not pretend that mammals can't survive at these temperatures. Humans survive at minus 40 and all the way to plus 50 C. We live all across this planet at all different types of temperatures. So let's not pretend that humans aren't adaptable and that 1.5 degrees is going to somehow eradicate humans on the planet. That's absurd.
Well, the question is this: is if it costs nothing whatsoever to stabilize CO2 back at what it was 100 years ago, would you be in favor of doing that, or do you think we're actually better off? As you said, we're probably, the planet is better off in a certain sense with higher CO2 because plants grow better. So the question is, if it costs nothing, how would you feel are you a father? Do you have kids?
Yes, sir. I have 7 and 9-year-old boys.
Great. Congratulations.
Thank you.
So yeah, so as a parent, would you prefer to give them the same CO2 level that allowed us to develop agriculture, or you prefer to give them a higher CO2 level?
Very simple. A very simple answer is no, I don't prefer to give them either because I don't trust that we understand the climate system enough to tinker with it. I think the unintended consequences of us messing with them puts their lives in so much more jeopardy than what's happened so far. I only can go by what's the observable data thus far, right? And so since we've been burning fossil fuels and since the about 1.2 to anywhere to 1.5, depending on which metric you want to use, of surface warming that we've experienced, we have had dramatic improvements in the human condition. My kids' lives will be better than my life. Your kids' and grandkids' lives will be better than your life. It's just hands down, the human condition has never been better because we have access to cheap, reliable energy. And it's just a very simple answer.
Wait. What does energy have to do with CO2?
Well, because right now, this primarily where the CO2 is coming from is the access to cheap and reliable energy. Land modification is probably half of it, so we could go half and half.
Right, but let's take that off the table. Let's assume we go nuclear or something, and we can stop burning fossil fuel. Okay.
Then again, no, I would say no. If it was free, completely free, no, because of the unintended consequences. You run the risk of tinkering with the natural environment and pushing us below 180 ppm. For what? For what? Because of imaginable computer models that are telling you that things are going to be bad in the future. That is not enough justification for me.
Hold on. Let me just interject only because I want to make sure our audience is following. If we didn't have an audience, I would let you guys, go at each other's throats. I love it. Okay. No. No. This is great, but I just want to get some definitional things. So, Peter, you mentioned. So we're talking about energy. We're talking about carbon dioxide levels. And Peter, you said You wanted to not have the carbon dioxide be directly tied to energy. And I think you're saying, what if we could produce energy, let's say from nuclear, right? So that we're not also generating carbon dioxide.
Or solar or wind. There are lots of ways of.
Right. Okay. And then Matthew.
Wait a minute. So solar and wind are highly mineral and energy intensive technologies. They will increase CO2 long before they decrease CO2. It's crazy that the idea of reducing CO2 in the environment is to go to mineral intensive and energy intensive technologies that require enormous amounts of mining and mineral extraction. And to think that that's going to lower CO2 blows my mind.
But hold on. I'm not, we could go down that path, Matthew, but I'm not sure I don't know that we want to go in that direction. I'm not saying we won't, but I want to come back to, rather than Peter, what, I'm going to take a step back. Peter, when you talk about your concern about safety with the amount of carbon dioxide in the atmosphere, and then you're saying humans have survived during a period where it was 280 to 300 parts per million. And it's only in the last 150, 200 years that we've, gone above 350 and now above 400. And it's still going up at a couple parts per million per year. But I think that your primary concern is, given that carbon dioxide is a greenhouse gas, and given that it makes in theory, makes the more carbon dioxide, the more the temperature goes up. I know there's some counter arguments to that, but let's just stick with that for now. That's your concern about safety. You're concerned it's going to get just too warm on the planet. Am I correct there?
Not quite, because I have a belief, and it's just a belief, that our our lives are closely intertwined with the ecosystems that we live in. And I don't know if it's temperature or humidity or UV or whatever it is, but again, as a conservative, I don't think, again, Matthew may disagree, and a lot of techno-optimists disagree, who say, let's just go to Mars and be done with it. That notwithstanding, I have a personal belief that our well-being is closely intertwined with our ecosystems that we live in. And that as we increase CO2 levels, we know that the ecosystems change very radically. And we don't know how because, you just, no one's.
Wait. Why? But hold on. When you say it changes very radically, I mean, one thing I've read about is that the satellites show that over the last 20 or 30 or 40 years, that the Earth has gotten greener. Is that one of the things that you're talking about?
Well, it might be, but I'm taking more of a generalist perspective and saying that I really, maybe Matthew understands more. I'm sure he's a professional, geochemist, so he understands a lot more than I do. But as just an astrophysicist training, it's like all I know is that the ecosystem is very complicated, and if you mess with it, weird things happen. We do know that a lot of cultures, indigenous cultures in the far north and the equatorial, they're disappearing because their ecosystems don't exist anymore. And again, they're not my culture, so maybe I shouldn't worry about it. But I have an attachment to this very complex, interesting world that I was given, and I'm interested in giving it back to my children and grandchildren.
But I would argue that those cultures in like the Inuits, their cultures have been disappearing since the last glacial maximum. It almost sounds like you're arguing for stasis, like you want stasis should be the answer. We should now stall the natural processes on the planet from changing because it would be inconvenient for the climate to change. A lot of the things I write about in my Substack is how the climate changes when the CO2 doesn't change at all. For example, like the Little Ice Age, right? There was almost no CO2 change at all. And we had this dramatic change in Northern Europe in terms of the temperatures, right? And so it's almost like you're trying to convince your grandchildren that if you could keep CO2 at some magical level, that there would be no more climate and no more possibility of bad weather and things like that. And that's just not the truth. And I just don't, it seems like it's funny because I'm the one that's called the climate denier, but I'm the one that argues that the climate's going to change regardless of the CO2 in the atmosphere. And we should be focusing on resilience. And there's 2.1 billion people on the planet right now that don't have access to clean drinking water. I don't think they really care that the CO2 is 422 or 25 parts per million. They don't. It's a privilege for you to be spending $1 billion a year to think about how to sequester CO2. But let's be honest, there's billions of people on this planet that don't care 2 cents. They don't give 2 cents about that because they have real problems to think about.
Okay, Peter, what was your question?
Yeah, so I like to approach these things like a business where first, with climate, the first question and in business is who's the customer? Who are we doing it for? And then what's the outcome we want to get for them? And by when? And then how are we going to do it? And so the reason I brushed off the energy question is that's a how. And that's the last question to discuss. The first is who are we doing it for? And it sounds like we are in agreement that we really want a beautiful environment and planet for our children. And then the question then becomes, okay, what would the measure of that be? I think what usually happens is people get so scared off by the cost based on what we thought in 1975 that the cost was going to be, about 10 or 100 years of global GDP. And so we say, okay, let's not give up on GDP. Let's look at another alternative. Well, since 1990.
Let me just interrupt. I'm not, when you say the cost, I apologize. The cost of what specifically? When you're talking about 1975, what cost are you talking about?
Yeah. So in 1975, given what we knew, and I'll speak for myself, given what I knew as a MIT student, was that the way to get CO2 out of the air was the way we did it in submarines and in the Apollo spacecraft. And that was going to cost about $1,000 a ton. And if you multiply that out, as I said, it comes out to about the total economic operation of the whole planet over at least 10 years. And that's clearly not going to happen. That, things changed. And so we now realize that there's strong evidence that we can do it for vastly less, for essentially zero. And now it's a question. And so now as long as we can imagine anything, we can say, well, let's imagine the most optimal outcome. And we had a seminar at MIT many years ago. And I asked that question, like, if everything were free, what would be the optimal outcome for the climate? And everyone agreed that getting CO2 below 300 parts per million was optimum, because we know humans have survived that. And we know science says 350 is probably okay, but probably okay isn't such a good deal for our kids. And then we said by 2050, and everyone looked at their gut. They said, yeah, 2050 is about right. Later than that, there's going to be enough eco-destruction. We don't know what's going to happen. Before that, we'll be called lunatics. And so we settled on this goal of 300 parts per million by 2050.
Listen, I have a question as to if you are a climate scientist and you said there's no problem with 500 or 600 parts per million. I don't know if any climate scientist is saying that. But the impression I have is that you're not allowed to even say that, like, you're not allowed to say that. You get kicked out of the club. I saw this is a little off topic, but I saw this great YouTube of Carl Sagan speaking to a Senate committee in 1985 and explaining how the greenhouse effect works, how it's not just on Earth, it's on all planets. It was so easy to understand.
It's because this idea that the level of greenhouse gases and the surface temperature are somehow correlated. And they are correlated in the last million years or so, as we've been going through these interglacial and glacial cycles. That's because CO2 lags temperature. So we know that as the orbital forcing that I was talking about before, where the Earth and the sun interact, that warms the planet, the oceans start to release CO2. But what we don't know is that whether if you change CO2, you force certain temperatures, because what we see in the past in the geologic record is that during very high levels of CO2, on the order of 4 times what we have today, 1600 ppm, you have a glaciation, the Andean-Saharan glaciation period. And sometimes at very, very low levels of CO2, you have very warm periods. And so the idea that the surface temperature is very sensitive to the amount of CO2 just isn't supported in the geologic record. And thus, I would argue that us trying to control the amount of CO2 in the atmosphere, we shouldn't expect much change in the surface temperature, which I think is the whole goal.
So, Peter, so that leaves me with a question. When you were at this seminar at MIT, and all these people said, yeah, it would be a good idea to be at 300 parts per million, would it be accurate to say that most of the people there were coming from the perspective that the Earth's temperature is primarily a function of the CO2 concentration?
I don't know that. If I had to bet, I would bet yes, but that we didn't discuss temperature because temperature is incredibly complex. So we were just really discussing it as parents, just saying, well, what do we know? And we know that during the Holocene, while we developed civilization and agriculture, CO2 was in this level. And we also know that as CO2 levels increased after we started burning coal, that temperatures increased correspondingly. And then ecosystems changed correspondingly. The losing of the ice cap, losing of the changing of the rainforest, loss of tundra, and so on.
So I agree with all of that. I think habitat destruction is a big problem. Species loss is a big problem. I would argue switching to low density fuels like solar panels and wind farms isn't going to solve that problem. In fact, it's going to exacerbate that problem. I would also argue that Peter, if you had your way today, if tomorrow you could snap your fingers and the level of CO2 would be back to 280 parts per million, like it was pre-industrial levels, there would be over 1 billion people that would perish in that year because crop yields would just suffer dramatically. I mean, billions of people may perish. I just don't understand that that's a benefit, how that's somehow beneficial.
Well, first of all, we can't reduce CO2 suddenly.
I agree.
And everyone agrees that when you change CO2 levels rapidly, that leads to a lot of ecosystem collapse. So we can take that hypothetical off the table, if you would. The methodology, how would we reduce CO2 and how would we produce energy? Well, if we decided that we wanted to put CO2 to historically safe levels, that human society has survived, then we could decide we want to keep burning fossil fuel. It's bad for the environment and bad for the health, but we could decide to do that. It's good for certain economies and bad for other economies. Then we can. It would be very easy to increase the CO2 removal from photosynthesis in the ocean. And we could do that, although I don't think that we would. I think we would work hard to produce zero pollution energy. Now, personally,
Peter, hold on. I want to make sure I come away from this knowing the answer to what's the cheap way to get carbon dioxide out of the atmosphere.
Okay.
Okay.
Yeah,
I want to make sure there's no mystery.
No mystery. Okay, good. So, I started with the expensive way to get CO2 out of the atmosphere, which is what the government is funding right now, which is direct air capture, alkalinization. Don't worry about what that is. Matthew knows, and it's a headache. Biochar, reforesting. There's really expensive ways that don't make a measurable difference. I think Matthew was pointing to that. So then the question is, well, what does work? And there's strong evidence. It's not proven. We won't know it until we actually get CO2 back down. That by adding the right amount of iron and possibly other minerals in certain parts of the ocean, primarily where you have an eddy, which is a downwelling eddy, and it knocks the biocarbon. So when you get photosynthesis, we call it biocarbon because it's carbon produced biologically. And when that gets drawn down below a certain level in the ocean, there's not enough oxygen and it doesn't rot, and it just stays there until the ocean chemistry changes. And as Matthew pointed out, we're not really sure what causes the oceans to re-emit that carbon later on. That's a bit of a mystery still. But typically it's tens of thousands of years later, and we should have really good technology by then for managing these things and understanding. Matthew could be right that we could get to 300 and then inch above that and say, if we go above 300, do things actually get better as you stabilize? And but that'll be long after I'm dead, so I'm not going to entertain that question.
Well, I think we know the answer to that, though, Peter, right? Because I think we both admit that a glacial period would be worse than 2-3 degrees of warming, right? I mean, I don't think anybody would argue that.
Oh, I way beyond my my expertise. I don't think, if I can be frank, I don't think any models give us an answer to that question.
Yeah,
so,
fair.
Yeah, you may think you have an answer, but I don't believe it. I don't believe any answer.
Wait,
I'm
a skier. I am so excited about the next ice age coming. I want to be able to ski all year round without having to go far from where I live near New York City.
You still need mountains.
Anyway, so that's sort of my premise is that I really don't know if, what Matthew's saying is possibly true, but there's research that needs to be done. And in the meantime, Matthew, I acknowledge your concern that it bothers me a little bit that over the short term, I'm advocating that we stabilize the climate like it was the last 10,000 years. Just hopefully stabilize the population at a level that we don't demolish our rainforests and so on. Stabilize things for a bunch of decades, and then figure out where we want to go. But let's get back to what I call a safe harbor, where we know we've been, we know it's safe, and then venture out into these adventures that you're discussing.
Do you ever ask yourself how maybe the 7 billion people on the planet that don't live in the Western world, especially particularly Silicon Valley, would think about that, your answer to that question?
Well, I've discussed it with a lot of indigenous, and I've discussed it with a lot of Africans. And to a person, they say, "Oh, if we could get the environment back to something like it was when I was a kid, that would be wonderful."
What is that environment? So I'm confused. So I'm 46. I grew up in Fresno. I've lived in Somalia. I've done a lot of work in Tibet. I've talked to impoverished people. And the one thing they tell me a lot, and the one thing I remember from 1985 to 86 in Somalia was power going out, going to sleep next to candlelight. When I was doing geology in Tibet, I would notice a lot of the children had these very dark boogers and coughs because they were using dung, yak dung, to cook and to heat their huts. And so if you look at a correlation of essentially fossil fuel use and energy use and pollution, it's exactly the opposite of what people think. People think that the countries that use a lot of fossil fuels have the most pollution, but it's exactly reversed. If we really want to help these people, if this is really the goal, we should set aside our obsession of CO2, realize that bringing these people up to a standard of living where they will have the same consideration like you do for their grandchildren, because right now they're worried about what's their next meal and are they going to be warm enough when the next snowstorm comes. If we can get them up to that standard of living without regarding CO2 and accepting and even embracing the fact that that's going to raise CO2 in the short term, we would be so much better off in the long term. But we're doing the exact opposite. In fact, we're spending, like you just mentioned, it would only be $1 billion or so a year. Maybe that's not a lot in Silicon Valley, but it's a lot in a lot of other places. And that money could be used right now to help these people with things like liquid natural gas to stop them from using dung and wood.
Yeah, well, I think you have a good point that we don't know. There's no knowing what the optimal energy mix is. And as I said, this conversation is about climate, not about energy mix. I do want to address your question about poverty, and that is, do you know how much larger is the human population now than it was in 1800?
Oh, significantly. I think that's when we crossed 1 billion.
Yeah,
it's 8 times now, right?
Yeah, so almost 10 times. So 10 times more than it was in 1760. And increasing any population in any environment by a factor of 10, almost always, if it's stable for 10,000 years, you suddenly expand the population by a factor of 10, you're going to cause that damage, and you're going to have a lot of poverty. You're going to have a lot of people in disease, whether it's people, reindeer, rats, cockroaches, whatever the species is. If the population explodes 10x, then you're going to have what we call poverty, suffering, disease.
Peter, I apologize. I'm going to rudely interrupt here. So you asked the question, how much have we grown since 1760 or 1800?
Yes. Yeah.
So how about if I'm going to ask a similar question, how much has the population grown since 1950? And I think the answer is 4 times, right? I think.
Yes.
Okay.
Close enough.
Close enough. Yeah. And that's still so basically, let's say between 1760 and 1950, the population doubled. And then since then, it's gone up 4 times in a much shorter span.
That's right.
Okay. Also, the amount of poverty has decreased, not just as a percentage. The amount of the population today that is severely malnourished, that has no access to electricity, I think is something like 10%. People, the percent of population that is easy access to electricity that doesn't, I should say, is probably more like 30%, right? But the amount of starvation, malnutrition, disease today in 2024 is, on a percentage basis, so much lower than it was. It probably in 1950 was 35-40% of the world lived in abject poverty. Now it's a much lower number. And so even though we've grown the population 4 times, I think that the absolute number of people in poverty is down. So I just want to challenge what you're saying. In part, you and I both, we know each other through an organization that was the philosophy started something called the Hunger Project back in the 1970s. And one of the things that the Hunger Project did was to promote the idea that there was actually enough resources, enough food, that we didn't have to have starvation. But back in the mid 70s, everybody thought that starvation was inevitable, that there just wasn't enough stuff. So that's why I rudely interrupted you, because what you just said, I don't agree with. It just doesn't jive with, clearly we live in a time frame when humanity is totally different than it was 200 years ago. We're 8 to 10 times bigger. We've created technologies that nobody could imagine 100 years ago. And actually now we're starting to depopulate. The wealthier parts of the world are shrinking. It's only the poorer parts of the world that are still increasing. Anyway, so now that I've rudely interrupted, let me hear what you have to say about that.
It's a very good point, of course. And again, there's a certain I don't know. And I have a belief that ecosystems are very complicated. And as I told Matthew, I don't believe the models. They're nice, but I think the real world is more complicated than the models are. And so that we do know that we are cutting down forests. We are extincting lots of species. We're draining the aquifers, and so on. And that will probably all have bad impact. And so, thinking about my grandparents, at the turn of the 1900, they were burning wood for heat, right? What else would you burn? But that was because the global population was less than a quarter of what it is now, and burning wood was a totally viable thing to do. Anyway, but the key thing that I find for affecting change is to a large degree separate the variables. So we have, I say, one variable, which is CO2 levels, and it's just based on the history. As I said, the 10,000 years we developed agriculture and civilization, we also had a very stable CO2 level. And as Matthew said, temperatures went up and down, but we had a very stable CO2 level. And all I can say is it's complicated way beyond my comprehension. I think beyond any computer comprehension at this point.
Peter, I love one thing, a couple things you just said. You talked about cutting down rainforests, and you talked about draining aquifers. Those are things I'm really concerned about. But almost everybody talks about carbon dioxide. My goal is by the end of this decade, the concern about climate change has just relaxed. It's just, people just don't worry about it anymore. Now, the only reason they would stop worrying about it is if they got intelligent about how the science works, which is why I want scientists who disagree with each other to talk to each other. Because if you actually hear both sides, you get a lot smarter, right?
Right.
And but if people stopped being so worried about carbon dioxide, then they'd actually have the space to be worried about deforestation, to be worried about aquifers. There's so many other things to be worried about.
Yeah, can I jump in real quick? Peter, I think you would appreciate this because you understand that there's a finite amount of resources and funding. But since I started in graduate school in earth science in 2008, I watched as so much of the NSF Geoscience Directorate funding just got vacuumed up by essentially just pushing CO2 and any sort of climate, any signal that they could put towards CO2. And so much a lack of funding and just a shrinking of the amount that was going to things like deforestation, habitat protection, species loss. And, there's only a finite amount of resources. And that was one of the things that made me so kind of upset was I was watching my funding dry up because I wasn't in the climate side. And I'm sure there's a little bit of angst there. But, part of my argument is that it's not bad to be worried about CO2. It's bad to be obsessed about CO2 because it sucks up so much of the practical environmentalism that I call that we could be doing in this idea that let's do something now and hope that it has an effect in 2050 or 2100.
I'm totally aligned with you on both of those points. That the climate budget is, in my observation, became totally political in the Reagan era when Reagan took the
solar panels
off, and it was just it was a call to arms for the left and the right to fight, and we've never stopped fighting. And when you're fighting, you don't get logical. It sounds like you sort of agree that if it costs nothing for a few decades to stabilize CO2 at levels that our society has survived, take a big breath society-wise, let our population get back to a nice level that we're not destroying the ecosystems for a few decades, and then let our grandkids figure out, okay, you've got a stable planet again, and your ecosystems are beautiful again. Go have fun.
I would tweak that just a touch. I would say that I would consider sequestering the amount that we believe we're putting into the environment. But if that number is still allowing the natural CO2 to change in the background, we should allow that to happen naturally without us tweaking that.
Yeah. And I disagree.
Wow, wait, hold on. You guys actually agreed on something remarkable. That was remarkable. So I have a question.
Yes.
Peter, it sounds like Matthew is saying, let's at least talk about what would it take to sequester the 3 to 5%. Do we know? So is that like 2 or 3 parts per million equivalent, would you say, Matthew?
No. So the total carbon budget's on the order of 700 and something 60 gigatons. And so, this becomes much more than what gets in the atmosphere because it's constantly recycling. So we just do it by gigatons, but it's on the order of 3 to 5% of what I believe is like 760 gigatons. Peter, I might be wrong, but
it's not good enough for today.
Yeah.
I maybe I think where my brain went when you said what you said, Matthew, is what if we sequestered enough CO2 such that the Keeling curve, which is the graph that shows how much carbon dioxide is in the atmosphere.
No, he's not saying that. He's not saying that.
No.
What?
Yeah.
No, the exact opposite of that. I'm saying that regardless of what the Keeling curve says, I'm okay if we say, look, as a global society, we're producing on the order of, let's say, 30 gigatons of CO2. I'm okay that we sequester 30 gigatons, even if CO2 keeps going up on the Keeling curve or goes down or goes sideways, who cares? Because we don't want to mess with Mother Nature. So let's just sequester what we're putting in and then let nature move the natural background CO2 as it would naturally without us messing with it.
And right now, are we sequestering any CO2?
Yes, there is quite a bit of funding that has gone into CO2 sequestration. I think we're on the order of, Well, there's a lot of funding, but it's on point.
Right. Those are different questions.
Well, that's right. Yeah. So a lot of money, a very little amount of CO2. Yeah. So a lot of funding, no sequestration. I agree with Peter.
But here's where we differ, and it's not profound, but it's fun. And so I'm proposing that we essentially remove the CO2 that we've poured in from fossil fuels over the last 100 years. And I can see the wincing on your face, and I honor that. And what I'm saying is, let's stabilize the ship, and then decide what we want to do. Because I assert that what nature tends to do with an obstreperous species like ours is flick us off. And I want to make sure that we stabilize the ship and stay on, and then start the next chapter.
We've only been around as a civilization for a very short amount of time on a 4.5 billion euro planet. So I don't think that there's any chance that anybody's flicking us off anytime soon.
Right. Anyway, so that's the biggest disagreement, and that's not a profound one.
No, I agree. Yeah.
All right. I think we're just about done. The only thing I'm left with is I still don't know Peter's secret, which is how.
Oh, how do we do it? Well, I can tell you. So how do we remove? Obviously, we don't know until it's done. But as I said, we have the data from 1992, and I've done a lot of work analyzing all the options. And and we're actually raising the funds and working with the Philippine Coast Guard to make this thing happen, is start out with 100 by 100 kilometer area, distribute about 100 tons of iron fertilizer, just iron sulfate that you put in your garden or on your corn crops or something. A very low density. It's about 1 milligram per square meter, so like a grain of salt per square meter. And we'll divide that up into 16 different regions. A 4x4 grid will have different concentrations and different formulations, and maximize the amount of CO2 removal. And then we'll also test the theory that it's the downwelling of the eddy that gets it out of the system. And then I consider it urgent to get CO2 to safe levels as a parent, and just scale it up from 100 kilometers, where we'll do, I think it's like 1 part in 1,000 of our emissions the first year, and then scale it up so that I think in 3 years we could actually get to the point that Pinatubo demonstrated of 20 gigatons a year, and then we can replicate that in 3 or 4 or 5 different locations and different eddies across the ocean. And each of those eddies would cost per year, per year about $20 million or something to provide the iron and the sensing. We don't need to do all the science. Again, Matthew was saying.
Did you say 20 million with an M? No, wait a minute. You couldn't even mine the iron sulfate for 20 million that you would need.
No, it actually, that's the commercial price. Yeah. It could be 500 million.
Wait, hold on.
So what about possible droughts that you would start in the neighboring countries next to those eddies that you were doing? What if you started it? What if the algal bloom was much larger than you ever anticipated, and you started a decade-long drought next to Chile or Brazil? Who's regulating you? Who gets to decide that you guys get to play with the climate? And there's no societal benefit to what you're doing. Right now, there's nothing that you can give me that says, like, if I do this, I get a benefit. If I give you cheap and reliable energy, you know that you get a benefit. You have a tangible benefit. What is the benefit that society gets from you guys tinkering, rich guys tinkering with a bunch of the rest of us, our climate?
One question at a time. So your first question is basically, is it safe? And if there's a problem, can we solve it before it grows? And the the safety abstractly is shown historically that it's never, that nature does iron fertilization constantly in the Atlantic and constantly in other coastal areas. So we're pretty confident that we know what happens when you fertilize the ocean with iron. And if something goes wrong, then you stop doing it, and the bloom will usually stop within weeks, certainly within 6 months. I don't think anyone can imagine it lasting more than that. I mean, but usually it's within 10 days as the bloom stops. So,
but how would you, let's say there was a drought in Chile.
Yes.
How would you know that it was caused by that?
Right. There's no reason to think it would be caused because, each year,
hold on. Let me go back to Matthew. Matthew, you said, what if you do this experiment and it creates a drought somewhere in Chile, right?
Yeah, I just mean you're tinkering with systems. So drought might be a bad example because fertilizing the ocean probably wouldn't do that. But what if you create a hypoxic zone where the migrating tuna that are Peru's major, source of fishing industry go into that hypoxic zone and they all die. And because the algal bloom sucks the oxygen, right? This is something that we try to avoid normally. If you talk about lakes and river systems and ecosystems, what we try to do is avoid algal blooms because they create what we call dead zones. So this is exactly what we spend a ton of money trying to stop fertilizers coming into the Mississippi River because they create the nutrients that comes offshore in New Orleans and creates this enormous dead zone in the Gulf of Mexico where there's no oxygen in the water and nothing grows. And so, maybe a drought was a bad example. That maybe would have been a better example of cloud seeding, which is another one of these geoengineering ideas. But for example, for iron fertilization, if you make an algal bloom and you strip away the oxygen from the water column, and an entire group of a school of fish come into that water zone, they will die. You're tinkering with Mother Nature, and I feel like you need justification to do it. And thus far, the justification isn't there. This idea that, humans have only existed at this CO2 or that CO2, to me, isn't justification enough to start messing with the natural ecosystem.
Yeah. The future is unknown, so we never know what's going to happen. We could be hit by an asteroid, which would change everything. But notwithstanding the stuff that we can't predict, we do know that the ocean fertilization, it's getting specific. So let's dismiss the marine cloud brightening and the stratospheric aerosol injection and don't worry about what those mean. Matthew and I know. Ignore all of those and just look at the one thing which is, I'd say, most critical, which is the ocean fertilization, which nature's been doing for millions of years. And it only works in the deep ocean. So the harmful algal blooms are coastal phenomenon, like you said, along the Gulf and where the Mississippi River empties in. And this would not be within many thousands of miles of there.
Wait, I thought you said it would be in the South China Sea. Did I misinterpret that?
Yeah, well, that's where we'll start because that's where nature demonstrated this 20 billion tons per year.
But wait, Peter, to be fair, the only reason they're on the coastal zones is because that's where the fertilizer is coming in. You're going to areas that are naturally have high phosphorus and nitrogen and injecting the iron. So you're basically making it into a coastal zone. So let me ask this question. Would you argue that iron fertilization would not change the dissolved oxygen in the water column?
Well, it would definitely, but nature has been doing this for millions of years, and nature has adapted. We know that there's low oxygen when you get below a certain depth, and since the beginning of time, which is 10,000 years, there wasn't any recorded time before 10,000 years. So since the beginning of time, nature has been doing this. And nature is well adapted to whatever oxygen changes happen.
Okay, I would argue that yes, nature does do it, but just understanding how nature does it mitigate the idea that when you do it, there aren't unintended consequences.
Well, there are unintended consequences. That's for sure. When the test was done in Alaska, they were shocked to see where they did it's something similar to what I described. They were shocked to see, first of all, that the salmon catch went up 5-fold. They didn't expect that. They expected maybe twice. And then they didn't expect that the orca whale population would explode. But since there was so much nutrients in the water, there had been essentially no orca births for like 6 or 7 years, and there were 5 2 years later, which is the gestation period of the orca whale. And so there were unexpected consequences, but they were all beneficial.
And do you assume that that's just the way it would be, or do you think about the unintended negative consequences?
Oh yeah, when we, again, I'm a Silicon Valley guy and have manufactured a number of products, and you always start with a pilot, and then you get bigger and you get bigger, and you're constantly checking for bad side effects. You've got to, and if you have to assume that.
So, Peter, are you anticipating this is going to happen?
Yeah.
And what time frame?
My intention and the design that we have is by 2030 to have it scaled up enough that the CO2 level is actually falling again.
But by 2030, the IPCC expects that the CO2 level would be falling naturally anyway, just with the current scheme that's going right now. I think 2036.
Wait, Matthew, you're saying the IPCC thinks that
the last one. So let me see. Oh, well, we have to pull it up. Maybe I'm a decade early. But remember that Peter's assuming that there's going to be no perturbations in any other system, which is 96 to 94% of the amount of CO2 that's coming in there. There's no perturbations in that part, so that the change in the 3 to 5% that we're putting out will be enough to change the global CO2.
But hold on,
I don't know how you'd ever measure that.
I've gotten lost. Peter, you're saying the question I'm asking is, when does this experiment start? Is it going to happen? And when is that going to happen? But I think what you said is by 2030, I didn't hear you say this, but I'm thinking what you meant is by 2030, this is going at full speed, and you're going to start to see the CO2 percentage in the atmosphere go down.
Yeah.
By your company alone, Peter?
No, you can't do it that way. You've got to have multiple companies doing it, and not my company. We don't even have a company for it.
Oh, sorry. Yeah. But the investments that you're making and stuff.
Yeah. So we're putting together essentially the pilot to get things started. It's interesting because all we have to prove to begin with is that we actually can do an ocean fertilization test again. Because the common belief is that it's impossible after 2012, and so
wait, hold on. What happened in 2012?
In 2012, a group out of Canada did a test just like I described. 100
Axios, right? Axios.
No. In 2012, it was called the Haida Salmon Restoration Project.
Is this what you were talking about the salmon and the orca whales?
Yeah.
Okay, so what is it about that you I'm sorry, what did you say? You said after 2012?
Yeah, after 2012. Again. So it's been in 12 years, and there's been no attempts to replicate it or improve it. And so the first thing to prove is that it actually can be done again, because people commonly believe that it's not even legal. And although there have been recommendations, as Matthew suggested, that wait a minute, maybe we shouldn't mess with Mother Nature. There are people who say that, and then some of us say, well, I want to make sure that our children have the same CO2 we had, and
well, Peter, I think what you're saying is we already are messing with Mother Nature, right? I think that's what, and you're saying we need to fix that, right? So, which is a valid perspective. I understand both of your perspectives, but how is it possible that by 2030 this will actually have been implemented and actually be already reducing the carbon dioxide in the atmosphere?
And who's funding it?
So the funding of it is really important, especially from the political perspective. And again, in business, you always want to figure out who's your customer, and then what section of those customers have money to pay for it. And so the customer for this essentially are again, you may disagree, but I think that our grandchildren would much prefer to have the same CO2 level we've had the last 10,000 years. All the ones I do. I mean, my brother agrees with me. He thinks that it's all about the plants. And
Peter, we just agreed that if you went to the 280 ppm, if you just snapped your fingers, which we admit you can't do, billions of people would be dead. So, like, this is a crazy idea. You're just telling people that you should die.
But wait, hold on, Matthew. Let's. I don't think. I just want to know practically.
Yeah, practically.
How is this going to happen? How is this going to happen?
Yeah. Okay, so the funding is going to come from what we call the grandparents. So the people who have a vested interest in the well-being of our grandchildren and great-great-great-grandchildren are the elders, the grandparents. And governments really have no interest in it. They have potholes to fill and wars to fight and so on. Trying to get the government to pay for restoring the climate is not a good idea because it's just not in their charter. The same is true of corporations, that corporations are there primarily to provide shareholders with their retirement. And, the shareholders don't invest in Microsoft for climate.
So, Peter, simply put, it sounds like you want to do a crowdfunding from wealthy people who are grandparents like you and me. And that you think that because it's not going to cost that much, that you could have a successful crowdfunding. Yeah. And I think you probably could. I wouldn't be contributing, but that doesn't matter. I think there's enough people out there who would, right? And so then once again, let's say you raised all this money by 2026. I just made that up.
Yes.
How do you get this effect that you're talking about by 2030?
Yeah. So step by step. So we'll start out with 100 by 100 kilometers and optimize it, which would take a number of months. And then either expand it to a larger area, assuming that there are no side effects that we don't want. And if there are side effects, and that's part of the optimization, is change something to get rid of those bad side effects if there are any. And then expand it to 200 by 200 kilometers, and then either expand to 300 kilometers, which was the size of the eddy in 1992, and also replicate it in other eddies.
Would you be willing to hire Matthew to be the devil's advocate? In other words, hire Matthew and he'll be responsible for making sure that these bad effects that he's worried about don't happen. You guys,
there's no way to know. There's no way to know. You just can't do it. That's the only way to know. You can't do it. There's no justification to do it. If Al Gore's right and billions of people are migrating and all of these things are happening, we can have this discussion. But until then, this is just messing with the climate. And ironically, it's the people that are worried about climate that are worried about things like food, agricultural collapse, and things like that. One of the ways that could happen is through our irrational fears about climate and tweaking the climate. I mean, it's so crazy that like the people that are solving the problem are the ones that are making it at the same time.
Yeah. Well, there's when I worry about people, there's a risk aspect, and that is, what's the risk, if we don't do anything, and CO2 will go to 450 by 2050 if we follow the IPCC, and that's 50% higher than humans have ever survived, and again, it'll be higher than it's been in 15 or 20 million years. What's the probability that'll turn out well? Don't know. If we restore CO2 using the methods that nature's used for millions of years, what's the risk? And we do it gradually. We've never seen any bad side effects, and if we see any, we can correct them. What's the probability of that being detrimental? And no one's done that calculation, and Matthew, you may want to start doing that. But I think it's about 1 billion to 1 benefit, that we're 1 billion times better off if we restore historically safe levels and don't until we stabilize the planet.
Not for the 4 billion people that survive on synthetic fertilizers today, not on the people that live on 50% fertilization, CO2 fertilization. I mean, Peter, you're talking about going back to a time period that could not sustain the people that we have today. So you have to do the cull. So you're going to have to be in charge of culling a certain amount of the population to get us back to those CO2 levels. Are you prepared to pick which people have to go and which people get to stay?
I'm a bit confused. Are you saying that that population is directly a function of CO2 level, and that if we reduce CO2 level, then that will reduce the population?
Currently, at the present 8.2 billion people that we have today, there is no way to sustain those people at a 280 parts per million level of CO2 with the current amount of land agriculture that we have. Because what we've seen is something on the order of 30 to 50% increase per hectare of crop yield because of CO2 fertilization. So you're just going to reduce the amount of food, or you have to increase dramatically the amount of land. So you pick. But that's
not relevant. I don't understand. Are you saying that when CO2 goes up, then the planet holds more people?
No, I'm saying the planet already holds more people.
Yeah.
And my primary concern is the sustainability and the well-being of those people.
Okay.
And reducing the amount of CO2 means we can't feed those people.
Why is that? That doesn't make sense.
Because current crop yields, in fact, in the last decade, because CO2 is so high, have we actually decoupled the amount of land that we use for the amount of crop yields that we get. So this is CO2 fertilization. So plants, like I mentioned before, so the optimum for photosynthesis is like 1,200 parts per million. That's why greenhouses, if you grow tomatoes in a greenhouse, you inject CO2 into that greenhouse such that the plant can actually grow much faster. And so what we're seeing is that per hectare of land, in the last 100 years, when CO2 has increased dramatically, we have seen a 30 to 50% increase in our crop yields. That has to do with machinery, that has to do with synthetic fertilizers, also from fossil fuels. But if you went back to 280 parts per million, you would reduce the global population on the order of 1 billion to 2 billion people, because you couldn't feed them with the amount of land we have. So you'd have to use a lot more land, but we both agree that we want to reduce habitat destruction and reduce the amount of land used. And so I just find that this CO2 obsession has this weird kind of hypocrisy to it, where it goes around in circles and claims it wants habitat protection, it wants to protect species, but it wants to bring CO2 back to pre-industrial levels, which means we would need way more farmland to feed the people, unless we're going to kill some people off. And I don't want to make that decision.
Yeah, that's really interesting. I've never heard that before. Because what I've understood is, as CO2 has gone up, I know if forest production has gone down. And
no, the planet is greened in general, everything. The deforestation has gone down. The sub-Saharan has greened. The NASA says 25% greening since 1985. Not only that doesn't mean just the foliage on every plant is more full. It means just more areas covered in green area from space.
Anyway, but I get what you're saying. You're claiming that as CO2 goes down, farm production will go down per acre. And I don't know if that's true or not. But the thing to keep in mind is.
But Peter.
Yeah.
Would you be willing to take a week and investigate that? In other words, you've been working on this project for a number of years.
Yeah.
To do this experiment with ocean fertilization or iron fertilization.
Yeah.
And
I can answer you.
Okay.
Yeah. So you're asking. I think you're asking, how do we make sure we do it safely if we do it? And,
well, no. I'm just asking you to investigate the assertions of somebody like Matthew, because you haven't heard them before.
Yeah, I know, but I'm not into theory. When I graduated in physics with my bachelor's in '77, things were changing really fast. And I left MIT thinking, in 30 years, almost everything I know now is going to be wrong. And I was right. Almost everything I learned in 1977 is now wrong. And so I'm not a big fan of theory. I'm a big fan of experiment. And so my answer is it'll take a long time for CO2 to come down significantly. And by then we'll know if the cost is too high, and we can just stop anytime and it'll stabilize. And if we need to burn coal, and we get together and say, you know what, we've got to burn some coal and raise the CO2, that costs nothing. So it's correctable. And the only way to do it is in experiment and test, not very carefully designed. You reduce it and see the correlation, correlate it with machinery and AI and all that stuff, and decide what the cost benefit is empirically, not theoretically.
I think this conversation could go on for another 2 hours, but I also think we should at least say this has been a great conversation. Maybe we come back and have you guys do this again. But I know we've been recording for about an hour and 45 minutes.
Yeah. Peter, thank you so much. Like I said earlier, I've got all the respect for you for sure. And I appreciate just having a conversation.
Great. Me too. I really appreciate it. None of the three of us will be the same after this.
Yeah, I agree. I agree. You've softened me a little bit on some of the things I was a little bit harder on.
Wow.
I would love to pick your brain on Silicon Valley and everything that's changing there in the whole climate realm. But maybe we'll do that some other time.
And this has been a remarkable conversation.
It's been a remarkable conversation. Thank you both.
Thank you guys. I appreciate it.